Hello, this video is to help out with Tech Project 7. It seems like the part that gives people the most trouble is part F, so I'm going to focus my attention there. I'm going to do a quick version of this with different numbers, so your numbers won't come out the same, but you should be able to kind of look at what I'm doing and get a decent idea of what you should be doing. So in part A, they want us to enter 893 for the number of trials, which is your sample size, and 0.753 for the true probability, which is your population proportion. So I'm just going to mix that up a little bit, and I'm going to use 781 for the sample size and 0.316 for the population proportion. So the first thing I need to do is open up the right sim, which is the proportion sim. So I'm going to enter those numbers in there. So for the number of trials, I'm going to enter 781. And for the true value of P, I'll put 316. Just make sure you're adjusting those to the numbers you're supposed to use. And then that's kind of it at first, and now you go off and do a little bit of work by hand. So the next part says to completely determine the distribution of the possible sample proportions and show your work. So I'm skipping the show your work part here for time and the explanations. I'm only showing the answer. So my answer would be P hat is approximately normally distributed. I need to explain why that is, or more specifically, you need to explain why that is in your answer. And then I need to give the details of that normal distribution, which would be that mu of P hat is 0.316 and sigma of P hat is 0.016636. You should see examples like this in section 7.2 if you're stuck on showing the work. All right, so I have that answer. Let's see what the next part is. Calculate the probability that P hat will lie within 0.03 and show your work for that. And you could do that work by hand to show the sketch and do the math, or I'm going to give you another option here using a stat sim, and I'll accept the stat sim option just as well. So your first job is to translate that statement. What does it mean that P hat will lie within 0.03, the true probability? Another way of saying that would be that your sampling error is less than 0.03. So you can look for examples like that to see what the work is like. I'm doing a different version. I'm doing within 0.02 of the true proportion. So if the true proportion is 0.316 and I subtract and add 0.02, I get these two numbers. And so your job would be to find the probability that P hat is between 0.296 and 0.336. Now again, your example has different numbers in it, so you won't be doing exactly what I'm going to do here, but it would be the same idea. So I'm going to use a stat sim to answer this question. So I'm going to pull up the folder again, and I'm going to do the normal distributions sim, and I'm going to put in the appropriate numbers for this. So let's see if I can get all this to show at once for you guys. So I want to answer this question right here using this information right there. So let me pull up the stat sim I need. So the lower boundary for my probability question is 0.296. The upper boundary is 0.336. It makes sense for me to use this normal distributions program to find the probability because we're saying P hat is normally distributed, but I do need to enter the mean and standard deviation. So my mean is 0.316 and my standard deviation is 0.016636. So I'm getting these numbers from my answer to part B. Again, your answer to part B will be different, so just use those numbers. And then when I click calculate, I'm getting the probability. I'm getting the area actually, right? And that area represents the probability. So this 0.7706 would be my answer. Your answer would be a little different. I would suggest capturing that with the snipping tool. So I'm going to go search for that on my computer. That's happening off to the side out of your field of vision. But the snipping tool has popped up. I'm going to click that I want a new snip. Move that out of the way and capture this screen. And I like using the snipping tool to do that because that way with the pen marked here I can circle the answer to that probability question, which is the area, and not have to worry about remembering to do that later. And then I can do edit copy, and then I can get that out of the way. Go to my report and paste that in, which would be the answer to C. So I'll put that right here. Control V and paste that in. And now I've got the answer to that probability question. Make that maybe a little bit smaller. Not too small because some of this stuff gets hard to read. But the probability that p hat is between these two boundaries. There's the boundaries, there's the sketch, there's the answer. Okay. So you can do that all written out by hand using your calculator, normal CDF, and show the work for your z-scores, or you can use this program really fine with either way. So you can pick on that. And then let me get to the part now that is giving everybody trouble. So enter 0.783 in the text box. That turns out to be 3% or 0.03 above that truth of 0.753. You should find that that ends up being this upper boundary on your probability translation. So I'm going to enter 0.336 in the text box, and that means I need to pull the sim back up. So the observed proportion, I'm going to put 0.336, my right boundary. They're telling you put 783, that should be your right boundary. And then it said to click automatic and let that run until this got over, I think, 1 million or something. Let's go check what it said. So yeah, let that run until there's at least 1 million of them, and then do an alt print screen and put that in your report. So let's go check in on that. Wrong one. So how we doing? Not there. 20,000. So the idea that we're going to do here in a minute is we're going to try to figure out the probability of this black portion of the graph. And unfortunately, there's nowhere on the screen that tells you what the area or percentage of the bars that are black is, but it does tell you the percentage of the ones on the left that are red and the percentage of the ones on the right that are red. And then the total area under a curve is 1 or 100%. So I'm going to use the idea that the area under the whole thing is 100%, subtract this 11% on the left and the right to figure out the percent of the black. In the middle, I just want to let this run and get over 100, and then I will show you the math on that. Getting pretty close. Slowing down, unfortunately, too. Not sure why that happened, but we're up at 600,000. Let's go just check in on the directions and see where we are. So yeah, so the directions are saying subtract those percentages from the left and right tails from 100% to get your answer. And this says what you need to do, but a lot of people get a little mixed up on it, so I just want to show you exactly what that's telling you. And getting a little lost on my windows here, and we're almost over 1 million. Somebody asked me today, they went like, I went way over 1 million, is that okay? Sure, no problem. You need at least 1 million though. Alright, so I'll go ahead and pause it there, and then I'll do what they were asking me to do. Try and calculate the area of that black portion. And I guess I better move this over here. So turn on my TI. The total percentage for a normal curve is 100. I'm going to subtract this red portion right here, which is 11.8973%, getting that right over here from the left tail. I also want to subtract at the same time this red part on the right. If I subtract the left and the right, all that should be left is the center part. And so the right part is that 11.2134. And so this would be the middle part, 76 point, let's call that 89%. So going to my report, I would type that math right there. Let me see if I can pull that calculator up so I can see that too. Maybe put that right here. So what is that? Part F. So I'm doing 100% minus, I'm going to have to pull that calculator up and get it out of the way so I can type, but I'm just going to type this right here into my report. So 100 minus 11.8973 minus 11.2134 equals 76.8893, and that is percent. I'm going to write that as a decimal too, so 0.768893. And then I still need to pull in that screenshot, so let me get that back. And I'm going to do an alt print screen on this. When I do alt, the graph's going to disappear, so I'll refresh. And then alt print screen again. is copy and put that into my report for part E. It's not with the E, that always bugs me, so I'm going to press enter over here a few times to force that E down with the graph that it's supposed to be labeling. Maybe get a space after that too. And we've basically got the step done that everybody gets stuck on. I'm just going to quick run through here. Part G says to compare the answers from up here with what you got. So first of all, we said we thought p hat would be normally distributed. These are p hats, very much bell-shaped. We said the mean of the p hats would be 0.316. After getting a million p hats, the mean of my p hats is 0.316. So that's actually matching exactly. The standard deviation of the p hats was supposed to be 0.16636. The standard deviation of my p hats after a million of them is 0.016629. That's a little different, but very close. I calculated that the probability of landing between 0.296 and 0.336 was 0.7706. When I simulated it, I got 0.7689. So that's a little different, but pretty close. 768 versus 770. That's off by about 0.2%, not that big of a difference. So you should write all that up. But on part H, when it asked me are the differences small or large, all those differences seem small to me, so I'm going to say it's small enough that they could just be random variation. If you're getting any differences that are substantially big, something has gone wrong. You shouldn't just say something's gone wrong. You should go figure out what went wrong and fix it. I hope that helps you get through some of the tricky parts of this tech project. All right, good luck.